Okay, so 5.6 is about proofs. I'm going to let you know right now, I'm never going to have proofs on a test, but I do think you need to be familiar with them and do them. So you do have homework, but you will not be having them on your test. And now that we're on the topic, I'm actually not going to have a chapter 5 test. I'm going to have things on your chapter 6 test that are from chapter 5, but we are not doing the chapter 6 test, mainly because I don't do proofs on tests. So here goes. So this is how you do a proof. It says, prove if V is midpoint of ST, then SV equals half of ST. So first thing that we need to figure out is what is assumed. That is always the first thing in a proof. So it is assumed that V is the midpoint of ST. Notice that it is the if. In your homework, it's going to give you 2 examples, and know that the if is the assumed. It's going to ask you, what is the assumed? And you need to know. It's the if part of an if-then statement. All right, so if V is midpoint of ST, that is assumed. So now we need to say that, okay, so if V is the midpoint of ST, then we know that SV would equal ST. And so that would be the definition of a midpoint. And because I don't do definitions on tests, that's why I don't do proofs, because I don't think you need to know exactly what each of these are. Like, you're going to have the distributive property, multiplication property of equality, law of deduction. I'm not going to make you look up all of those, and so I'm not going to make you do them on your test, but you do have to do them in your homework. You have your book in front of you. You have all the resources you need. All right, so we know that SV equals ST definition of midpoint. So now we're getting closer to figuring this out. And so then we also know that SV plus VT is going to equal ST. We know that this plus this equals that. And that is the definition of between. So you may want to look on your examples to help you with some of these definitions. All right, so the next one would be that okay, so we are going to be doing SV this time. Sorry, I wanted to make sure I followed this right. So SV plus, because VT is the same as SV, we know that SV plus SV equals ST. And we know that through substitution, because we're substituted this right here. Now we're going to do the distributive property. So we know that 2SV, because we're doing the distributive property, and remember that is when we have AB plus C equals AB plus AC, kind of the same thing. So we know that 2SV equals ST. That's a distributive property. Now, if we were to divide both of these by 2, we would then have SV equals 1/2, because that divided by half would be ST, half ST. This would be the multiplication property of equality. And then what we then could say, if V is the midpoint of SV, then ST equals half SV. That is the law of deduction. And I'm just going to put an arrow So we now know that is the law of deduction. So that is what a proof is. I am not going to spend a lot of time making sure that you are able to do proofs. I'm not going to make you do tons of them, but I am going to make you do the ones in the text. Remember, you do have the teacher text, and you can always use that to help you with some of the definitions. But I want you to really think about it just so that way you can understand what deductive reasoning is. Just as I'm not going to make you memorize, this is modus ponens. But I am going to have you do it for your homework. So you will need to look back in your book. This is on page 190. So modus ponens is a method of deductive proof with the following symbolic form. So the premise is, if P, then Q. Remember, that's what that means when it has that arrow. If P, then Q. So last time, our premise was, if V is midpoint of ST, then SV equals half ST. That's what this is saying, except for it's just saying P, if P, then Q. So the premise is P, and then the conclusion would be Q. So if you want to figure, so if they ask you, well, what is the premise? You say P, if V is midpoint of ST, and then conclusion would be Q, or in the earlier case, SV equals half ST. So they go on further to say, okay, premise one. So the premise was, if P, then Q. So here it says, if, yep, just a moment. Go to bed, please. Okay, go to bed. Sorry about that. So it says, if man is sinful, then he must die. Romans 6:23. So the premise would be the if part. Man is sinful. And the conclusion would be, man must die. That would be the then part. And you're going to do it just like that. It's pretty self-explanatory, very easy once you understand what they're asking you to answer. And then I'm going to show you another definition. Again, you're going to use it for your homework, but I'm not going to have you memorize it. This one is slightly different. It says modus tollens. It is a method of deductive proof with the following symbolic form. If P, then Q. This time, the negation of P. So if the opposite of P, then the conclusion would be the opposite of Q. There it goes, turn back on. I think it got dark for a couple of them and I didn't notice. All right, so the proof for that, I'm not going to write it all out, but the given or the assumed was if P, then Q. And then we know that the negation of Q looks like that. So then, using the contrapositive rule, theorem 5.2 from earlier, we know that the negation of Q, if the negation of Q, then the negation of P. The negation of P is the modus ponens, step 2. And then, I think I'm in low power mode. I bet you that's what's going on. So then, if P, then Q, and the negation of Q, if then the negation of P. That would be the law of deduction. So I'm going to just move just a little bit here. Another definition with the transitivity. And I'm going to do a lot of your homework with you, or at least explain your homework. So feel free to pull out a sheet of paper in just a moment for when we start to do your schoolwork. So transitivity is a method of deductive proof with the following symbolic form. If P, then Q. That is our premise. So then the other premise would be if Q, then R. And then our conclusion, so if P, then Q, and if Q, then R, then the conclusion would be if P, then R. Could you just kind of follow that down? All right, so this says, example 3, classify the fallacy committed by this argument. All dogs are mammals. Fido is a mammal. Therefore, Fido is a dog. First, symbolize the argument. If D, then M. And so if all dogs are mammals, then if all dogs are mammals and Fido is a mammal, then Fido is a dog. So the conclusion, Fido is a dog. This would mean, therefore, all dogs are mammals and Fido is a mammal. So we know that, this is this is kind of logic. All dogs are mammals. Fido is a mammal. Fido is a dog. We know that it could be many different type of mammals because not all mammals are not dogs. So that does not mean that Fido is a dog. And they determined that based on, and I'm going to pull this back up because you're going to need to do this during your homework, and I'm actually going to do a lot of your homework with you. Let's see. Come back in. So modus ponens is a method deductive proof with the following symbolic. If P, then Q. So the premise was Q, conclusion P. Q, excuse me. So that's how we determine that. But then it goes on to talk a little bit further about a different fallacy. So this one would be modus ponens. And the next one is going to be that modus tollens. And I'm just going to remind you of what that is. It's if P, then Q. So the negation of Q would mean that the negation of P. All right, so let's look here. Okay, so now we're back on this. It says, recall that reversing these statements form the converse of the given premise. So if instead of if D then M, we're going to change it to if M then D. If Fido is a dog, then all dogs are mammals and Fido is a mammal. That would be actually true. Likewise, the argument below contains a fallacy, though it may at first remind you of modus tollens. The name of the fallacy is assuming the inverse. So it's very similar, except we're not doing the inverse of both. Oh, I guess actually we are. Therefore, okay. So all dogs are mammals. That is if D, then M. Fido is not a dog. So if Fido is not a dog, then Fido is not a mammal. That actually would be true. And we would know that doing the the modus tollens. All right, so now I'm going to start doing your schoolwork. If you want to pause it, grab a piece of paper. I'm going to help you with this just because, and I think 6-1 is also doing the same thing. So I'm going to walk you through this. So if you want to try it on your own, I encourage you to do that. Otherwise, feel free to follow along. All right, so suppose you want to prove the vertical angle theorem using the law of deduction. If two angles are vertical angles, then they are congruent. So what should you assume? And remember, the assumed is always the first part, if two angles are vertical angles. So the assumed is two angles are vertical angles. So that would literally be your answer for number 1. Number 2, what should you derive from the assumption? Okay, so we know that So we know that it would be the then part. That would be what we would derive from the assumption. So they are congruent. What are they? Two angles. So two angles are congruent is what you would write for number 2. Number 3, suppose you know that angle 1 and angle 2 are vertical angles. Number 3, what would you conclude from the vertical angle theorem? That they are equal. Number 4, what rule of logic lets you draw this conclusion? And what we would end up saying, because that's when number 4 is actually why I feel that I wanted to do this with you. That is because of the modus ponens. If P, then Q. I always feel like when we start doing definitions that sometimes it's hard to know just what you're answering, just because this is math class and I find that a lot of students get confused. That's why I'm doing this with you. So sorry about the coughing fit. Suppose you know that angle A and angle B are not congruent. Number 5, what could you conclude from the theorem? Well, you could conclude that they are not vertical angles. So what rule of logic lets you draw this conclusion? And that would be the modus talens, whoops, the modus talens, because that's talking about the opposite. So that is why it would be the modus talens. All right, and now number 7, if A, then B, and if B, then C, then what? Then we would know that if A, then C. And we know that from the transitivity. Right there, the transitivity. All right, going back over here. Okay, identify the fallacy in each of the following arguments. If smoke comes from a house, it must be on fire. No smoke comes from the house, therefore the house is not on fire. This is assuming the inverse. So that's what we were just talking about. I don't feel like the text really does a great job of explaining, but that would be what we're looking for, is when you assume the inverse. So you assume the modus talens. Okay, so then if the temperature is above 100 degrees Celsius, then water will boil. The water on the campfire was boiling, thus its temperature was above 100 degrees Celsius. And then this one would be assuming the converse. So, right up here, I'm going to switch over to proofs. And you're going to go up to number 20. I'm not sure how far I'm going to go into it. But, so we are wondering what number 10 is on this side. And you can look back in your school or in your textbook, but I'm just going to walk through it. Assume P. So we know that this is what we know is the if part. So assume for law of deduction. If P, then Q, that is given. If Q, then R, apparently that is also given. So what do we know about Q? And we take a look at both of these. So we know that it would be, we're talking about modus ponens. And then R, taking a look there, we're also talking about modus ponens. So then, if P, then R, so if P, then R, we're then talking about the law of deduction. And we're just going to pull up the law of deduction again. And, oh, there it is, right there. So, the law of deduction. All right. Now I'm just going to take a look here, look at the following arguments and state the form of deductive reasoning used. Okay, so we're going to be looking at either modus ponens, modus talens, the transitivity, the law of deduction, and that's going to be 13 through 18. I'm going to let you do that yourself. And then give the symbolic logic from needed to prove each of the following modus ponens. So you're basically going to be looking at the information that in your book. You're going to be writing what is underneath modus ponens, and then you're going to be writing what is under transitivity. So, and then I think I might have also had you do the cumulative review.